Okay, so here's problem number 6 out of section 15.4, which is asking you to find the mass over the region given by y equals 0, y equals 2x, and x plus 2y equals 1. That's a triangular region. The first thing we're going to do is graph that region. And then after finding the mass, I want to find the center of mass, meaning where is my balance point, so to speak, where if this was a flat actual region, that if I could balance it, and it would be able to balance at that one single point. So mass, we talked about, was just doing a double integral over the region. So we're going to graph the region, find our bounds. We want to do a type 1 or a type 2, meaning are we looking at vertical lines or horizontal lines to bound my functions. To find center of mass, I'm going to have to find my moments first, which is the moment of x and the moment of y. And then I'll divide those by the mass, and that'll give me my point x bar, y bar, which is the center of mass. Before we start, this is going to be very computational heavy. Okay, so there's going to be a lot of integrals, a lot of busy work to keep track of. So as we go through, I'm going to be pausing, stopping and starting, cleaning up the board, saving our information on the side, because I only have this little space to work with. At those points, I'll go ahead and make note of it so that if you're trying to finish the problem and then use my work to check yours, you'll be able to do that as we go through. So the first thing we're going to do is look at the region. That hasn't changed since we started 15.1. The first thing I want to do is always check my region to see what I'm integrating over. That's telling me if I'm doing rectangular or if I'm going to switch and do it in polar. I'm guessing now before I start, we're probably going to use rectangular because I don't have the equation of a circle. Okay, so y equals 0 is across this way. Y equals 2x. And then x plus 2y equals 1. So there's graphing my region. So the first thing I want to do is start looking at what is my region going to be. So now looking at this region, I have a choice. If I'm going to do type 1, that means that my x value is going to be from some number to some number, and then I'm going to bound y by a function of x. So if I look here, if I'm drawing values for x, I'm going to have to switch functions from here to here. That means I'm going to have to set up my integral as 2 separate regions to account for the fact that at that point, I'm switching from one y function to another y function. So instead, as I drew my lines here horizontally, I'm going to use y values that go from here to here. And then I'm going to bound my x values from this function to this function. So let's see what that looks like real fast. So what I'm going to do is I'm going to rewrite these so I have x equals, so it's going to be y over 2. This line here is going to be x equals 1 minus 2y. So my x values, when I'm looking at my region, they're going to be less than this, but greater than this. So I need to look and see where my y values go from. My y values, these lines are starting at 0, but I need to know where I stop up here. So to figure that out, let's set these two things equal to each other. So this tells me y equals 2/5. That's this y value right here where they're going to cross. So that puts my bound. Oop. So with this information, this allows me to write my iterated integral. So we'll do is we'll write my double integral. My y values are going to go from 0 to 2/5. And my x values are going to go from y over 2 to 1 minus 2y. So then I want to integrate over my density function, which is just x dx dy. So that's a setup. So if you want right now to go ahead and work through and find this, the mass, I'm going to erase the board real quick and organize my information a bit. I'll be right back. Okay, so I got the board cleaned up a little bit to make some more space. I still have my region over here so we can reference it. Here's my balance for x and y. What I have is the formula for mass. So I have the double integral with y going from 0 to 2/5 and from x going from y over 2 to 1 minus 2y of x dx dy. So what I'm going to do is first, let's look at this integral on the inside. I'm just going to worry about this and do that in purple right here. So the antiderivative of x is x squared over 2. I'm going to evaluate that between y over 2 and 1 minus 2y. So I'm going to pull out that 1/2. I'm going to take 1 minus 2y squared minus y over 2 squared, which is 1/2 of, this turns into 1 minus 4y plus 4y squared, and that's going to be minus y squared over 4. So that's 1/2. 1 minus 4y. Here, I need to combine like terms, right? So to make common denominators, that's going to turn to 16/4. It's going to be plus 15 over 4y squared. So now this is going to turn into 1/2. I'm going to take this coefficient. I'm going to put it out on the outside. So I'm going to have 1/2 the integral from 0 to 2/5. 1 minus 4y plus 15 over 4y squared dy. I'm going to pause. So if you want to go ahead and keep going, we're going to integrate this next. Okay, so real quick, we cleaned that up. We just integrated the box, what's in the purple box here, and we got this as my antiderivative. The 1/2, the coefficient, we moved out to the outside here because we'll deal with that afterwards. So what we're going to do is go ahead and evaluate this now. So I have 1/2 times, that's going to become y minus 2y squared minus, this is going to become a 1/3, so that'll be 5/4. Y to the 3rd. I'm going to evaluate that between 0 and 2/5. So I'm going to get 1/2 times. Notice when I plug in the 0, I'm just going to get 0 as my answer. So I'm only going to worry about this 2/5 that I'm plugging in here. So that's going to be 2/5 minus 2 times 2/5 squared minus 4/5 times 2/5 the 3rd. Next thing I'm going to do is I'm going to start simplifying these. So starting to simplify, I'm going to have 1/2 times, that gives me 2/5. I get minus 8/25 minus 5/4 times, that's 8 out of 125. The next thing I need to do is let's go ahead and try to simplify as much as I can. This 1/2 that I'm going to distribute through is going to give me 1/5 minus 4/25 minus, let's see, that gives me 8. 8 is going to give me a 1 on top. There's 5, and that will turn into a 25. A fifth minus 5/24. So let's see what that is. So this is just going to be 5/25. Hold on, something's not right. All right, so we got something wrong. So I'm going to go back and check. This antiderivative should be a plus. Ooh. Hopefully you caught that before I got all the way down here to my answer, because I shouldn't have 0. These are plus, plus, plus. So it's going to be minus 3. So when I make common denominators, that's 5/25 minus 3/25 is 2/25. Ooh. So I guess one of the pluses is if I was in class, you guys would have called me out on that already. Okay, so that's the mass of this lamina in that triangular region. So we're going to have to keep that in mind so that we find center of mass. I'm going to have to divide my moments in x and y by that 2/25. So keep that in mind. The next thing we have to do is do the moments. So let me clean up and we'll do that. Okay, so here we are. The next thing we're going to do is find the moment about the y-axis. So that's going to be the double integral. Y values go from 0 to 2/5. My x values are going from y over 2 to 1 minus 2y. So now what I'm using is x times the density function. So I'm looking back and I'm referencing my formulas that are right over here. So my is the x value times the density function. So it's going to be times x dx dy. That's going to give me this integral from 0 to 2/5 of y over 2. 1 minus 2y, that's x squared dx dy. So when I find my antiderivative, that's going to be 1/3 x cubed, evaluated from y over 2 to 1 minus 2y. So another way to make our notation or to write our work. So previously what I did when we did the mass is I did my side work and then I plugged that back into the integral. Another way, if you want to keep your work kind of flowing like this, is that I can take my antiderivative and evaluate it and keep keep it inside the integral. So if I'm going to bring that over here to simplify it, I'm going to get the integral from 0 to 2/5. And then it's said here, now I have 1 minus 2y. So I'm moving the 1/3 to the outside. 1 minus 2y, quantity cubed, minus y over 2, quantity cubed, dy. So when I write out that next step, I'm just going to simplify these here. So I'm going to have 1/3, the integral from 0 to 2/5. So when I multiply this out, I'm going to get 1 minus 6y plus 12y squared minus 8y cubed. That's when I multiply out the binomial. When I multiply this out, I'm going to get minus y cubed over 8. So now taking this, I need to combine these two like terms. This will be 64 over 8. So minus 64 over 8 minus 1 more would be minus 65 over 8. So this is going to turn into the integral of from 0 to 2/5 of 1 minus 6y plus 12y squared minus 65 over 8 y to the third dy. Okay, so again, at this point, I'm going to stop and I'm going to erase pause for instantaneous and keep going, you have a chance, if you want right now, to pause the video and then check after. So here we keep going. We're almost done with finding the moment about the y-axis. I need to find the antiderivative here. So I have a 1/3 that was on the outside. So I'm going to continue that 1/3 down. Antiderivative is y. Antiderivative is going to be 1/2. So that's 3y squared. Antiderivative is going to be 1/3. So that'll give me 4y cubed. Antiderivative here is going to be 1/4, so that'll give me 65 out of 32, y to the 4th. And then I want to evaluate that between 0 and 2/5. Again, just like before, when I plug in the 0, all of this just goes away and I get 0. So I'm really only interested in plugging in the 2/5. So that's 1/3 times 2/5 minus 3 times 2/5 squared plus 4 times 2/5 cubed minus 65 over 32 times 2/5 to the 4th. So then one more step, 1/3, I'm going to start simplifying. 2/5 minus, that's going to be 4/25, 4 times 3 is 12/25, plus that's 8 over 125, so that's 32 out of 125, minus, here I'm going to have 65 over 32 times 2, 4, 8, 16 over 25 times 25 is 625. Little more. So from there, I'm going to tell you that is equal to 31 over 750. So next what we're going to do is we're going to find the moment about the x-axis. So here we are now, we're going to talk about the moment about the x-axis. So let's go over and use our formula. I'm going to figure out this one next. So I need to take the double integral over the region. I'm still using the same region. Oh, it doesn't look good. So our y is going from 0 to 2/5. Our x value is going from y over 2 to 1 minus 2y. Now I have y times my density function, which is x, dx, dy. So what I want you to notice is these variables are different from one another. So this y is just a constant, so I can go ahead and pull it out. So I'm going to have the integral from 0 to 2/5 y times the integral from y over 2 to 1 minus 2y of x dx dy. I like this because, hey, we already calculated this integral when we did the mass at the beginning. So a lot of times make sure that you're checking, because when you're figuring out mass and then center of mass, you might be able to reuse your information more than once, right? So I'm going to take this and let's write that down here. I have from 0 to 2/5 y times, I'm going to have the 1/2 on the outside, and then I'm going to have 1 minus 4y plus, remember that's why I messed up last time, 15/4 y squared dy. So now here, let's distribute my y. So I'm going to get 1/2, the integral from 0 to 2/5. That's going to give me y minus 4y squared plus 15 over 4 y cubed dy. So now I find an antiderivative. I'm going to have 1/2 sorry about that. 1/2. So I'm finding the antiderivative of this, right? So that's going to be 1/2 y squared minus 4/3 y cubed plus 15 16ths y to the 4th. I'm going to evaluate that between 0 and 2/5. So I'm going to go ahead and pause or clean up and rearrange that up at the top if you want to do that, and then check your work with mine. I'll be back in 1 second. Okay, so I jumped ahead just slightly. I went ahead and I took the antiderivative that we had to evaluate at 0 and 2/5. Recognizing the 0 doesn't do anything, so I'm just plugging in 2/5. I'm going to simplify all my fractions first with the powers, make common denominators, add them together. I'm going to get 7 out of 750. That's going to be my moment about the x-axis. So the last thing I need to do is I need to put this information together right here and talk about the center of mass. So x bar and y bar. Notice it might not seem reasonable, but when I'm finding the center of mass, the x value deals with my, the moment about the y-axis, because those are talking about the distance x away from, okay? So it looks like those are switched backwards. That's the way it's supposed to be, okay? So x bar is the moment about y divided by the mass. So my moment about y, we said that was 31 out of 750, divided by my mass was 2/25. Y bar is the moment about the x-axis divided by the mass. Let me write that over. Let's finish this one first. So that's 31 out of 750 times 25 over 2. That's going to give me 31 over 60. Little more space down here. So let's look at y bar. That's going to be mx divided by the mass. So that's 7 out of 750 over 2 out of 25, which becomes 7 over 750 times 25 over 2. That ends up giving me 7/60. So the center of mass is this ordered pair at 3160, 760. That's going to be the point on the graph. So it's a little bigger than a half. It's going to be like right there. So that's finding the mass and the center of mass given a region and given a density function. Problem 18 will be the next one that I do, and that's talking about the moments of inertia and then the polar moment of inertia. So we'll look at that next. Different video, sorry, not after this video. Different video, we'll do the inertias. Thank you. Questions, post them on the discussion board. Send me an email. Let me know how everything's going.